This is Anusha. In today's video, I will be discussing about ranking and distribution window functions. The distribution handling functions are used to understand how data is spread or distributed across values, often to study variability, percentiles or rankings. These functions are widely used in analytics, statistics and data profiling. In today's video, I will be discussing the following distribution functions. First we have row number. Row number assigns an individual number to each record. It is useful to fetch the latest transactions, to fetch the latest price update or the most recent purchase for customer. So to demonstrate row number, I would be considering the transaction table which is as follows. So when I use row number by ordering it by sales amount descending and I am partitioning it by region. So in every region, here I am giving the row number 1 should be filtered. So in every region, whatever the latest record would be there, that is filtered and given. So these are the latest transactions per region. In the same way, there is a rank function. Rank function assigns a value to the record, but it ranks according to the metric we are giving or the performance. So it is useful to show top performing products, regions or top performing employees. So here we have used the same transaction table and the rank function, and we can see that there are ranks are given individually to each region. But here we can observe that when two sales amount are same rank is given, but the next rank is skipped. So we are getting gaps in the rank. So if our situation is to need a continuous ranking, that time we use dense rank. So here you can see the same table. So here when two sales amount are equal, it is given equal rank, but the next rank is the consecutive number. There are no gaps in the ranking. So it is ideal when you want a tie without skipping ranks. Next, we have NTILE function. It is used to segment records into n equal size groups like tiles. So first we will demonstrate this function using sales performance table which we have here. So when I have these business teams use NTILE to identify top 25 percentile of performance or regions or bottom 25% performers. It is used for incentive planning, performance benchmarking or resource allocation. So here I have used the NTILE function and I have given n as 4 so that I want to divide the data into 4 quartiles. So when I divided, this is the 1, 1, 1, this is the first quartile, these values come under second quartile and this is third and this is fourth. So if you want to interpret, so Deepa, Harsha, Amit and then Jatin, they are top performers because they are in the first quartile. Whereas Farhan, Bhavna, Keshav and Kavya, they are second quartile, means they are strong performers, but they are we have to target them for next level incentives or leadership grooming. And then we have the third quartile performance who are mid-tier performance, and the last are the underperformance who need mentoring. So in this way we will be able to divide the data into number of tiles. Next we have a percent rank function which calculates relative position of each transaction metric within the dataset. The lowest value is 0 and the highest is 1. Everything else falls proportionally between 0 and 1 depending on rank. So let's see how it works. So for the same table I have used the percentage rank function by ordering by total sales. So the percentage rank starts with 0 and then ends with 1, that is the highest value. And in the middle we get the percentage ranks. So if we want to understand like the Harsha's employee name performance, the Harsha's sales percentage rank is 0.92%. That means Harsha's total sales are higher than 92% of all employees in the dataset, and he is among the top 8% performers. Since 0.92 falls within the top quartile, Harsha belongs to the top 25%. Percent rank, normalizing ranking when datasets have different sizes and comparing relative performance. It is used for recognizing and giving eligibility for performance-based rewards, for benchmarking practices that can be modeled for other regions, or to understand high performer and worth retaining employees. Next, in the percentage rank, here again I have tried to demonstrate percentage rank in the other data set, and here you can see you can see same percentage rank. So here, but we can't see the top one. That is because the top two records, the transaction ID 107 and 108, have same sales. If you have ties, they share the same rank. Next we have a cumulative distribution function. So here I have given a cumulative distribution functions which is group by region and order by sales amount. So we got by region, we got this cumulative distribution. So here in the West 0.25 means 25% of the region have sales less than this one. And for the South, it is 50% of the regions have less sales than this. And the East and North are coming under the 100%. So this is how we interpret. We will try cumulative distribution with the other student score table. So here also when I used cumulative distribution, we can see the percentages. So if we try to understand Vikram's score, Vikram's cumulative distribution score is 0.5. That means Vikram's score is greater than 50% of all students in the data set. In the same way, if we have two subject scoring like English and Maths. So Maths is a more scoring subject, whereas English is not that scoring as it's a language subject. But when we want to compare the comparison between the performance, so direct comparison by marks is unfair. After applying cumulative distribution, both subjectives have a percentile scores between 0.1 to 1. Even though math scores are higher, overall cumulative distribution shows relative position within each subject, making comparison fair across distribution. In a company, we use cumulative distribution to compare sales across regions where revenue potential differs. In education, it is used to standardize grading across easier or harder subjects. That's all for the distribution functions today. Thank you.